Hi everyone. First of all, I would like to say thank you. Thank you to Rakuten for having us today and for this amazing prize. My name is Suzana Ilic. I'm the founder of Machine Learning Tokyo, and on behalf of our team, on behalf of the MLT team and the MLT contributors, we are very grateful to be here today and to receive the Rakuten Technology and Innovation Silver Award. Thank you very much. A very respected computer scientist and AI pioneer, Andrew Ng, said that AI is the new electricity. And this is quite some statement. What he means by that is that AI is transforming industries. It's transforming basically everything that we know. And by looking at some numbers, there's a lot of studies out there that show that the AI market is going to grow. And this Ernst & Young study shows how the AI market in Japan is going to grow over the next year. And looking forward to 2030, the market size will increase to 87 trillion Japanese yen, which means that all of these industries that you see will be impacted. AI will have an impact on business, on education, on healthcare, and it will be part of our everyday lives. And we already see it. We translate, we search, we auto-reply. With machine learning, we use personalization and recommendation. And even though machine learning systems are not perfect, they are helping us to make better decisions, to make our work easier, faster, and better. Now, what exactly is machine learning? And this is part of what we are as a community, as an organization. We want to democratize machine learning and the knowledge about artificial intelligence. And looking at this, you will see that artificial intelligence is a very broad term. It encompasses many different things, such as rule-based engines and expert systems, and also more general machine intelligence terms such as robotic, NLP, and computer vision. Now, machine learning is a subset of AI. We're talking about algorithms that learn from data. In breaking it down to its most fundamental principle, in a supervised scenario, a machine learning algorithm learns to map inputs to outputs. Simple as that. And deep learning is yet another subset. It's a subset of machine learning, and it's a complete game changer. And we actually heard today a little bit about machine learning. It's a game changer in the sense that with the access to large-scale data sets and to more compute in the form of GPUs and GPU clusters in the cloud that are accessible at all time at a very low cost, this allows us to process data with very complex patterns such as images, video, audio, and text, and achieve state-of-the-art results at scale. Now, this is exactly what is going to have an impact on everything that we know. It's going to impact us as individuals, as a collective, and as organizations. And I'll give you just a few brief examples. This is a very famous example, actually, of the Japanese cucumber farmer whose son helped him by developing a deep learning system that is sorting cucumbers. Sorting cucumbers is a very labor-intensive work. It's very repetitive. It's taking a lot of time. And building the system learned from thousands and thousands of images of cucumbers, learned to identify different quality levels of cucumbers, and deploy to a real-world system that includes software and hardware. It is able to not only detect those cucumbers, but also automatically sort them. Now, this system is by no means perfect, but I think it's a great example of how to be creative, how to think outside the box, how to find different areas of application for machine learning. Another one, and we heard this in more detail from the CEO of LPixel today, this is at scale. This is going to have an impact at scale. This is going to change and save people's lives, where deep learning systems are developed by researchers and engineers to help doctors with their diagnosis, detecting pneumonia, segmenting brain tumors, and liver tumors and other diseases. So we really do believe in machine learning having a positive impact on society and building systems that can positively change our lives. This is exactly what we did. Because we realized 2.5 years ago, okay, this is a technology that is going to change a lot of things. We wanted to be part of it. And in Tokyo 2.5, 3 years ago, there was no community out there that was actually building systems, that were actually writing code. So we started a very small group, just 2 people. It was me and Yuvraj Shinde, my co-founder. And we met every week. And we wanted to learn about artificial intelligence. And we actually did every week. We implemented algorithms. We trained neural networks here on the right side. On the left side, we deployed our first face recognition system and combined it to robotic elements. So we really wanted to dig deeper, to get our hands dirty and to build systems ourselves. And over time, this was in July 2017, and over time, more and more people started to join us and started to not only learn about it, but also write code. And more and more engineers and researchers joined us ever since. And here you can see some of the images of some of our meetups in the course of the past 1.5, 2 years that we held. We held a lot of hands-on workshops with state-of-the-art algorithms, writing and training neural networks. We held hackathons. We held events. One of our largest events was held this year in March at the University of Tokyo with Francois Chollet, who is the creator of Keras, a high-level deep learning API coming from Google. We had all these amazing opportunities, not only to involve the community, but also have world-class, world-leading experts in artificial intelligence in Tokyo. Today, Machine Learning Tokyo consists of 3,900 members here in Japan. We have a core team of 12 members, of 12 engineers and researchers, and about 40 to 50 active contributors who are providing resources, writing code, working on open source projects, working on open education, and much more. And one thing that I want to point out here is that our community is so big and our teams are so large, but these are all volunteers. So they all have full-time jobs. These are highly skilled talents, but they do dedicate their time and their effort not only to develop their own skills, but also to work on projects for AI, for social good, for projects that benefit others, and to help other people with open education efforts. Now, because our community was growing so big, we decided to establish Machine Learning Tokyo as a non-profit Ipanchadan Hojin earlier this year in May with a very clear mission, and I mentioned this earlier on. We want to make AI as accessible as possible. We want to involve all people into the discussion of building AI systems and the implications, especially looking at it from AI for social good perspective. And the way we democratize machine learning or help support democratize machine learning is through open education, through open source, and through open science. In the past 1.5 years, MLT held more than 60 AI workshops, study sessions, and talks with over 4,000 participants in Tokyo. MLT teams are working on machine learning, deep learning, and robotics projects in the field of AI for social good, and we're open sourcing all of our efforts. In the field of open science, we're also publishing research. Some of our teams have published research papers in top-tier machine learning conference workshops such as NeurIPS, and we're continuously collaborating with universities and research institutes in Japan, including the University of Tokyo, Tokyo Institute of Technology, and RIKEN. One of our projects that was recently completed in the field of open education was with Stanford University, where we worked with the technical assistants there to translate their CS 2030 deep learning course notes from English into Japanese. And this was really amazing because 12 bilingual volunteers from the Machine Learning Tokyo community, data scientists, engineers, researchers got together. We held several workshops. We met and we together looked at the course material, we translated, we reviewed, and we finally brought this to what you can see here. It was published on the Stanford website, on this GitHub. So this is very important for open education because this helps us to make high quality education from top level universities such as Stanford as accessible as possible. It helps Japanese speakers and machine learning beginners and students. Another project that we're working on, and I mentioned it briefly, we're very much interested in how we can use machine learning for social impact. And one of our projects is a team of 15 engineers and researchers who are all the way from software engineering to hardware engineering to machine learning, working on a project for agriculture. We're working together with Hack a Farm, a community of farmers and technologists and engineers in Chiba. And we visited there, we talked to local people, we talked to farmers, and some of you might know that people in rural areas in Japan are getting too old or sometimes even sick, and they cannot take care of the vast fields and crops anymore. So there is a need for automation and to build systems that can actually help and support the farmers there. And our project is a suspended robotic system, and I'll briefly talk about it. It's a little bit technical, but not too much. What we basically do is we use quantized deep learning models on low power edge devices for robotic systems in agriculture. Now this is a very interesting project because it combines machine learning and hardware. What we did basically is, on the right side you can see we have a mathematical reconstruction of a 3D space. And this can be deployed in any kind of space, in any kind of environment, such as a greenhouse. And this kind of concept can also be translated for many different tasks, such as object detection, object recognition, and pick and place tasks. What we did is we built a predictive model, a deep learning model that learns this mathematical reconstruction, and it's able to predict the motor movements of the robot to move this robotic system from its home position to its target position. Now that is not so exciting up until now, but we're able to deploy this on a very small edge device, on a microcontroller. And we run it on inference time on this microcontroller. And this has the potential to change a lot of things because it is very, very fast. It is fast on-device inference. We don't have to send data back and forth to the cloud. Everything stays on this device. Data is processed on device. It's fully offline. We don't need Wi-Fi. We don't need any kind of internet connection. And it's very, very low in terms of power consumption, and it's very low cost. Now, this is not only relevant for Japan. This is also relevant for developing countries, where agriculture is the most important source of income and the most important source of food production. However, people in developing countries are lacking resources and they're lacking infrastructure. Now, having deep learning models that learn certain constraints from different environments and are deployed on very small microcontrollers, on single core and multi-core for different tasks, for example, this could indeed be a game changer for many developing countries. And we are very honored that this work was also accepted at the NeurIPS 2019 workshop, Machine Learning for the Developing World, and will be presenting next month in Vancouver, Canada. Now, this is just very briefly shown what we do. We're working on dozens of projects. We're holding 3 to 5 events per month. We're supporting the community, and the community is supporting back. And I think it demonstrates and it shows really well the impact of this community, the impact of the technical talent here in Japan, and what we can achieve together in a collaborative, in an open, in an inclusive environment. And I mentioned this earlier on, I'm speaking on behalf of the community, I'm speaking on behalf of our team and our contributors. Thank you very much for being part of MLT, for making this an amazing community and making this an amazing organization. This award is for you, for all of you who are working on projects and workshops and helping others and contributing to AI for social good. And I would like to conclude my presentation with a recent news article that said that Japan will seek to increase the development of talent proficient in artificial intelligence to 250,000 people a year, up from just a few thousand today. So there's still a lot to do, but I think this is a very important statement, and I support this statement. I think that we should involve many, many people into the discussion of building artificial intelligence systems. We need brilliant minds, we need talent with many diverse, different technical skill sets, not only machine learning, but a lot of different skill sets. And we need domain experts, we need people with business expertise. And generally, everybody should know about the impact and about a general state of artificial intelligence. And we're honored as MLT to be a very small part of this, and we will keep supporting the AI ecosystem in Japan. Thank you very much.